we've got the integral of 0 to 1 of the natural log of 1 plus x divided by 1 minus x. So we'll separate these out into two separate logarithms. We'll have the integral from 0 to 1 of the natural log of 1 plus x, take away the natural log of 1 minus x. And we'll actually think about these as two separate integrals. So we'll whack a dx in there and then integral sign with 0 to 1 in that little bit. And now for both of these, we're going to do substitution. So on the left, u will equal 1 plus x, so du is equal to dx. And on the right, we'll have a v is equal to 1 minus x. So dv is equal to minus dx. So let's rewrite these integrals, and we'll actually leave the limits now, and just at the end, we'll transform back into the x world instead. So we'll have the integral of the natural log of u, du, and the right-hand side, these two minuses will make a plus. So we'll have the integral of the log of v, dv. Both of these integrals are the same, so what we'll do now is we'll just solve one of them and say that it's the answer for both of them. So if we do by parts, we can have the thing to differentiate as the log of u, which when we differentiate it gives us 1 on u, and the thing to integrate will just be 1. So when we integrate that, it gives us v. So the answer for each of them is going to be, well, u log u for the first one, minus the integral of u dash v, so 1 on u times u, which is just 1. Integrating that gives us another u. And now the same for the log v, but with v's instead. So plus v log v minus v. We'll transform everything back into the x world. So for the u, it's 1 plus x. So we'll have 1 plus x multiplied by the natural log of 1 plus x. Take away 1 plus x, so take away 1, take away x. And now plus, for v, it's 1 minus x. So we'll have 1 minus x multiplied by the natural log of 1 minus x, and then subtract minus 1 minus x. So that's going to be a minus 1 and then a plus x. These two x's, the minus x there and the plus x there, will cancel. Now everything we're left is in terms of x, and there's nothing to cancel off. So what we can do now, we can substitute in our limits of 0 and 1. And what we can actually think about is which bits of these are going to be 0 straight away. So if we look down here at this little section, if we put in a 1, this would be 0. So that's going to go away. If we put in a 0, this is going to be the log of 1. So this whole thing is just going to cancel off straight away, because it equals 0. And on the left-hand side then, when we look at this thing, if we put in a 1, we'll get a 2 there and a 2 there. And if we put in a 0, we'll get a 1 and a 1. Log of 1 is 0. So we're going to have 2, lots of log 2 from this term here. Everything else will be a 0, apart from these minus 2's, but they will cancel out as they're minus 2 in each term. And our 2 log 2 is the same as log 4.